Okay, so we're going to be dealing with position, velocity, and acceleration. Okay, so we need to remember to do this that just like how um, f, f prime, and f double prime relate in functions, so does position, velocity, and acceleration, because position, the first derivative of position is velocity, and the second derivative of position is acceleration. Okay, so basically this is the relationship that they have. So if we have a particle that moves along the x-axis so that its velocity at any given time is v of t equals 2t minus 3, and x of 0 equals 3, that means at x is the position at time 0 equals 3. Okay, it says find the equation for position of the particle as a function of t, x of t. So they want us to find the position equation. Well, that means if velocity is s prime of t, so if we take the derivative of position, we get velocity. That means if we go the other way, if we take velocity and take the antiderivative, we get position. So that's part A. A. So we start with v of t, and this is a really simple one because we know basically, we've done it a million times, what do we take the derivative of to get to t? Well, that's t squared. Minus, what do you take the derivative of to get 3? That would be 3t, because the derivative of 3t is 3. Now, there is a 0 there at the end, so what do you take the derivative of to get 0? Well, that could be some constant, okay, because the derivative of any constant is 0. Okay? Now, the reason that they've given us this right here is to help us find what c is, because they're telling us if we plug in 0, so if we plug in 0 for t, which gives us 0 squared minus 3 times 0 plus c, it has to be equal to 3, which means 0 minus 0 plus c, c equals 3. So part A, this is our answer. X of t equals t squared minus 3t plus 3. Okay, that's the answer for part A. Now, part B. Part B says find the position of the particle at t equals 3. So they're asking us to find x of 3. So using the equation we just found, 3 squared minus 3 times 3 plus 3, which is 9 minus 9 plus 3 equals 3. Okay? All right. Now, part C. Part C is asking us at what value of t does the particle change direction? Well, since position will tell us where it's located, right? My velocity, where it changes sign, that's where a particle changes direction, because velocity has its speed plus its direction. So if my velocity is positive, it's going forward. If my velocity is negative, it's going backwards. So you can't get to the negative side to the positive side without going through 0. So that's what we're going to do. We're going to say v of t, okay, to find where it's positive or negative, we need to first find where it is 0. So we set our velocity equal to 0, which means t is equal to 3 halves. Okay. Now the only other thing we need to do is double check and make sure, well, what if I plug in, say, 1? What's the velocity there? Well, if I plug in 1 to my velocity equation, I get negative 1. So my velocity is negative there. Well, what happens when I plug in, I can't plug in 2, I gotta plug in bigger than 1 point. Well, I could plug in 2. I'm going to plug in 3. 3 times 2 is 6 minus 3. That's positive. So sure enough, my velocity, or my particle changes direction because my velocity goes from negative to positive. Okay? So that's important. So that's the answer for C. At what value of t does the particle change direction? At t equals 3/2. That's when the particle changes direction. Changes from going backwards to going forwards. All right? And then part D, where is the particle when the position is a minimum? Well, we just figured that out. Part D, we're finding a minimum. Well, how do you find a minimum? So if we're finding the minimum of position, you take the derivative, which is velocity. You set it equal to 0, which we already did. This 3/2 is a critical point. And since we did our first derivative test right here, we saw that this part, the position, is decreasing here, and on the other side it is increasing. So my minimum occurs at 3/2. If you graph this using the points we already know, so we know when x is 0, sorry, when time is 0, right here, time is 0, position is 3. We also know that right here as well, at 3, we get 3, because we already did that in part B. We also know that there's a critical point at t is 3/2. So the last part of part D is to go, okay, well, what is x of 3/2? Well, that's 3/2 squared minus 3 times 3/2 plus 3, which is 9/4 minus 9/2. And I'm going to change this to 12/4 to get common denominators. So this is 9 minus 18 plus 12/4, which is 3/4. So that means that when x is 1.5, which is, our time is 1.5 right here, my position is there, which means my position graph looks like this, which makes sense because position is quadratic. And there we go. So this is my position at time 3/2. And that's what they're asking. It says, where is the particle when the position is a minimum? And the particle's at 3/4. So this problem is all about, it looks like it's about velocity, position, and acceleration, but what it really is about, it's about first derivatives and their functions and how they relate. And that's the most important part, is that you have to know that basically they're asking the same thing.